Hello, I'm Tyler Lucci. I'm a chemical engineering PhD student in the Lux Lab at Northwestern University, and I'm going to be talking about how our lab used synthetic biology to develop a point-of-need test for detecting lead in drinking water. There are over 9 million lead service lines providing drinking water to people's homes across the United States. These lead service lines pose a risk to public health because lead from these pipes can enter drinking water and subsequently be consumed, leading to a range of negative health consequences. Because of this, the EPA has established limits for lead in drinking water of 5 or 10 parts per billion. Water systems are therefore required to monitor drinking water for lead at customer taps. However, you can't see, smell, or taste lead in drinking water at these concentrations, so how can you tell if it's there? One approach is to use gold standard analytical chemistry methods. However, these methods are expensive and time consuming at a cost of 50 to 100 or even more dollars per sample and a turnaround time of days to weeks or even longer to get results. This motivated us to explore if we can use synthetic biology to develop fast, cheap, accurate point of need tests to detect lead in drinking water. Over the past year, we were able to develop a point of need test that detects lead in drinking water at 5 parts per billion in under 30 minutes. Our test functions similarly to a COVID test. To use our test kit, the user first adds 1 drop of water to the test tube using the provided water dropper. Next, the user mixes the sensor solution using the provided mixing tool. The user then waits 15 minutes for the biosensor reaction to occur. The user then adds buffer solution to the test tube. This buffer solution is similar to that used in COVID tests. Again, the user mixes the sensor solution using the provided mixing tool. The user then inserts a lateral flow assay strip into the test tube. After 10 minutes, the strip is ready for interpretation. We recently developed a web application for interpreting test results, where the user simply navigates to our website and points their smartphone camera at the test strip. The web application then automatically detects when the strip is in focus and snaps a picture. The user then hits the Analyze button, and our AI-enabled software analyzes the photograph and communicates to the user if the sample was detected to have above or below 5 parts per billion lead. We believe that our technology will support decision-making around drinking water systems by enabling large-scale monitoring of EPA regulatory compliance and by helping to identify lead infrastructure that poses the highest risks to public health. Thank you for the opportunity to apply to the Fall 2025 Tech Challenge.